All right, hey everybody, welcome to Pre-Calculus. This is on transformation of functions. So now that we watched the video on how to, what all the different transformations look like and how they actually take a function and slide them around, slide them up, down, left, right, reflect, or these non-rigid transformations, these stretches and shrinks. Now I want to actually show you guys how we can experiment with these in Delta Math. So I'm going to go over a couple Delta Math problems with you. Because these are problems that you're going to see in your homework, obviously. I want to make sure you know how to use them. So in these types of problems, there's several different types of problems in Delta Math, but in this type of problem, you actually have to look at the function and make the appropriate transformations to the graph. So if we're looking at this function, it's an absolute value, which we recognize as that sharp V. And we notice a couple things. So we have a +1 on the inside that's going to move the graph left 1. So we're going to talk about how to do that. And then the negative on the outside is a reflection across the x-axis. Again, all these types of things, hopefully you're studying. And then +2 is going to go up 2. So kind of make sure, first and foremost, you follow them in order, right? So if you kind of go to the inside first and then you work your way out. But I want to notice that first, the green dot that's always going to be in the center is how you can make a rigid transformation. If you click on that green dot, notice it doesn't shrink or stretch it. You're just moving it around wherever you need to move it. And then the blue dots where you could actually, apply a shrink or a stretch. So you could actually move those blue dots around and you could go, really kind of stretch it vertically or this way and squash it, what have you. And if you ever move things too much, just hit the start over button. You always go back to where you began. So let's actually follow these in order. So +1 means to the left 1. Hopefully you guys know that. And then I need to reflect it. So for example, you can grab any one of the 4 dots that we see here, or actually 8 dots. But for example, this dot right here is at -2, 1. Well, if that gets reflected across the x-axis, it's simply going to take the +1 for the y and move it down to -1 for the y. So instead of being at -2, 1, we're at -2, -1. And then finally, we're going to move the whole graph up 2. So once again, grab that green dot and move the whole graph up 2. Now, before you hit submit your answer, the one thing I'd recommend checking is, check a couple, or if you have time, all of the blue dots, okay? Make sure that they all work. So let's look at this blue dot right here in the bottom right-hand corner. It's at 3, -2. So just make sure that if you plug in 3, you end up getting -2, and that's a nice way to kind of confirm that you're on the right track. So 3 + 1 is 4. The absolute value of 4 is 4. A negative on the outside makes it -4. -4 + 2 is -2. So that dot is in the correct place. When I plug in 3, I get -2. And I'd recommend checking a couple of them, if not all of them, if you have time, just to make sure that you got them right. And then when you go ahead and hit submit answer, hopefully you get that check mark there. All right. So let's do another one here just to kind of show you this and just to go over a couple of these. So here's another one. It's clearly a quadratic. We see the square there. On the inside, we have a -5, which is going to go to the right 5. And on the outside, we have that negative. Remember, a negative on the outside of the function is a reflection across the x-axis. So first off, let's go right 5. So I'm going to grab that green dot and move it right 5. And then I got to reflect everything down across the x-axis. So for example, this point right here at 3, 4 is now going to be at 3, -4. And take your time lining it up and making sure it's correct. And then again, check some points, right? So for example, this dot right here is at 4, -1. Let's just make sure that that's correct. 4 - 5 is -1. -1 squared is +1, but the negative on the outside goes back to -1. So 4, -1 is a good point. Submit answer, get that green check mark. Okay, here is another problem. This steps up the ability level here a little bit. Now we're going to start introducing those shrinks and those stretches. And this is where it gets a little bit trickier, so just got to be careful. So again, this is a cubic, and there's the basic cubic function. I'm sorry, not a cubic, a cube root function. And now I just got to apply these transformations. So I see a -5 on the outside is going to take me to the right 5. And a 2 on the outside is going to be a vertical stretch of 2. So be really careful with these. So first, let's go ahead and do the x -5. Let's go ahead and move this to the right 5. So there we go. That's nice and simple. All right, so then, really take the time. Look at this point right here. It's at 6, 1. And we say, okay, well, where should that point be? And again, use the function here, right? Use the function. So if I plug in 6, 6 - 5 is 1. The cube root of 1 is 1. 1 times 2 is 2. So this point that's at 6, 1 should be moved, stretched up to 6, 2. Again, confirm that just by plugging 6 into the function and making sure that you get 2. All right, and then again, check this other one. Like, for example, right here we have 4. 4 minus 5 is -1. The cube root of -1 is -1. -1 times 2 is -2. So that point is in the correct spot. And let's just check this other one here to really confirm. If you're going to submit this, I know this is just a homework and you can get them wrong. It's not a big deal. But on a quiz, you really want to make sure you can confirm this. So if I plug in -3 minus 5, again, use your calculator if you need to, especially with cube roots. Maybe you're not as familiar. -3 minus 5 is -8. -8 raised to the 1/3, which is a cube root, is -2. -2 times 2 is -4. So we do get that point at -3, -4. And then when you go ahead and hit submit answer, hopefully you get that green check mark. All right, here's another one. This one is a cubic, x cubed. And we notice that the first thing is the timesing by 2 on the outside is going to be, again, a vertical stretch up 2. And then a +2 on the outside is going to move it up 2. So let's handle the actual stretching of 2 first. So again, notice this point right here is at 1, 1. If I plug in 1, 1 cubed is 1, but then I got to times it by 2, so it becomes a 2. But that was just the first part. That was just the vertical stretch. Then the whole graph needs to be moved up 2. All right, so again, confirm, double check that these points are working out. So if I plug in 1, 1 cubed is 1, 1 times 2 is 2, 2 plus 2 is 4, so I do have a point at 1, 4. Submit your answer and get that check mark. All right, let's try one more here. This is an exponential function, 2 to the x. This is a basic. Now, again, I know there's several transformations going on here, but the basic parent function that we're seeing here is 2 to the x. 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. We see those blue dots there. All right, now, I see first that there's going to be reflection that negative is inside the function on the x. Remember, when you're a negative inside the function, that's a reflection across the y-axis. Again, across the y-axis. So this point that's at 2, 4 is now going to be at -2, 4. That's an easy thing to handle, right? And the same thing, the point up here that was at 3, 8 is now at -3, 8. And again, that should make sense, right? Think about when I plug in -3. If I plug in -3 for x, there's already a negative there, so the two negatives cancel out, and you get 2 to the third is 8. So that's why it went from 3, 8 to now -3, 8. So that's that reflection across the y-axis. But now there is a vertical stretch up 4. So now all these points need to be stretched up 4. And again, use the points to really walk through this. So for example, let's look at this first point here, -1. If I plug in -1, it becomes a +1 because there's already a negative there. 2 to the first is 2, 2 times 4 is 8. So this point is going to get stretched up to 8. And at that point, the other points are off the grid because they're all going to get stretched outside of the viewing window of the graph. No big deal. Hit submit. Hopefully you get that green check. Okay? All right, now you're also going to see this type of problem, which I think is really cool, is they don't even define it as an absolute value function, but we clearly see it's an absolute value function. We're just calling it f of x. And notice how in the boxes here, you're actually going to adjust these boxes to get the black graph that they start with to transform into the red graph. So I think this is a really cool activity. So first thing I noticed is that it obviously is now going down. So it must have got reflected across the x-axis. The reflection across the x-axis is a negative out in front of the function. And notice as you change it, it occurs. I think that's pretty cool. Then we're going to move it left 6, which is going to be a +6 inside the function. So we're going to put a 6 there. And then watch it move. So cool. And then we're going to do one more. It's going to be down 3. So it's going to be a -3. Again, they have a plus sign here. You can't change the plus sign, but if you make it a -3, plus and negative is the same thing as a minus. And then after you click outside, it moves into the box. Once it's all met there and confirmed, go ahead and submit it, and you'll get that green check mark. So I think these are really cool problems. Let's look at this one. Again, it's another absolute value function. It clearly got reflected across the axes, and then it went down 6. So we'll put a -6 in there, and you actually see it. I think that's pretty cool. I think it's pretty neat, and I think that it allows you to explore it. And as you make the adjustments, if it's not lining up with the red dotted line, it's clearly wrong. You're going to keep making adjustments until you get it right. And the final type of problem that you're going to see is one where it's actually multiple choice. So they give you a black graph and a red dotted line, and they want to know, select the following that actually creates that graph, right? So again, in these types of problems, you really don't need to know what type of function is. We're just speaking generically. So if I want to move these two graphs, I got to figure out what's happening here. So if I look at the black graph to start, it looks like it gets moved down 1. So like I'm just looking at, say, this min right here. This min goes from -5 to -6, and then it goes to the right a little bit as well. So it looks like it's going to go down 1. So it's probably either this first choice or this second choice. It's definitely not going up 1. And then again, now I'm noticing that it's moving to the right. And remember, a movement to the right is going to be a -1. So it looks like it should be this answer here in the top right. They're not labeled A, B, C, D, sorry. But this answer in the top right here that I've selected in blue, again, it's going down 1 and right 1, which is the minus sign inside. And hopefully after you select that, you'll get that check mark. So I think those are some cool problems as well, where you're just viewing the two graphs, the old and the new, and you're kind of seeing, you're selecting which graph makes that happen. So those are different types of problems you're going to see, so make sure you understand how to work with those. And I will say they can be a little bit tricky, so you may take a couple tries until you start getting a bunch right in a row, but once you start getting a rhythm for how they work, I think you'll be fine. The biggest issue, or the number one thing I could recommend, is especially the problems with the blue dots. When you're all done and you think you're ready to submit, make sure to check those blue dots. Plug in the X, make sure you get it. If you don't, then you got to move it around so that you do get it. All right, guys, hopefully that helps get you ready for the Delta Math problems that you're going to see.